Hi, so for today we're going to talk about integration by algebraic substitution, and this has a similarity on the previous U substitution, but in the previous U substitution we only offset a certain constant outside the integral, then perform the basic integral. But in this algebraic substitution we will get still the derivative, then rearrange some of the variables in order for us to solve that integral problem. So for example, for number 1, 8x, integral of 8x plus 1 over square root of 4x minus 3 dx. We have here the given. Okay, how do we perform algebraic substitution? We must let z, we call that a variable z, is equals to square root of 4x minus 3. 4x minus 3. So let me just rewrite it clearly. Okay? And what are we going to do is to get this, express this equation in terms of x. So what are we going to do is simply square both sides. We have z squared. We have 4x minus 3. Getting x is simply z squared plus 3 over 4. And what do we do next is to get the derivative with respect to x on the left side and the derivative with respect to z on the right side. So we will perform that differentiation. We call that dx. Okay? Derivative of this is simply dx, 1 dx. Okay? And the derivative of this is 1/4 that we just factor out the constant. The derivative of z squared plus 2, 3 is 2z plus 0 or dz. Okay? Because the derivative of constant is 0. So we have now the value of dx is equals to 1/4 2z. We can simplify this further to 1/2 z dz. So we have dx is equals to 1/2 z dz. Okay. Once we've done that, we can simply substitute these variables into our integral such that we can find now the integral of 8x. What is the value of our x? The value of our x is given by this. We have z squared plus 3 over 4 plus 1. Okay, because of this plus 1. Multiply that by dx. What is our dx? Our dx is 1/2 z dz. Here is our dx. Okay, divided by square root of 4x minus 3. That must be our z. As you can see here, the z's will simply cancel. Okay, and we can simplify this because it's a constant. So 8 divided by 4 is simply 2. Okay, if we're going to simplify that, we can factor out 1/2 outside of the integral. So we have now the 1/2 integral of, distribute 2 on this, 2z squared plus 3. Okay, I'm sorry, 2z squared plus 6 because 2 times 3 is 6 plus 1. That should be 7. Okay, dz. So again, we're going to integrate this. This should be easy. Okay, because this is only power formula. 2z cubed over 3 plus 7z plus c. Okay, so we can see here that if we're going to distribute the 2 or the 1/2 inside of our equation here or expression here, so the 2 will cancel. So we have now z cubed over 3 plus 7/2 z plus c, and then we're done. What are we going to do is to back substitute the values of z. So we have now z cubed, the value of our z is square root of 4x minus 3. So we have square root of 4x minus 3, since that is a cube, raised to 3 over 3 plus 7 times the square root of 4x minus 3 over 2 plus c. Or to make it look nicer, we can express this in terms of exponential. Okay, exponents, I mean. 4x minus 3 raised to 3 halves over 3 plus 7 halves, okay? Multiply that by 4x minus 3 raised to 1 half plus c. Okay, this shall be our final answer. Okay? Okay, so now we're done with number 1. Okay, you can also choose z as 4x minus 3 and then perform the integral. Okay? So for our number 2 problem, so we have here number 2, the integral of y cubed multiplied by 2y squared plus 1 dy. Evaluate that integral. So what are we going to do is the same algebraic substitution. So we have to let z is equals to the square root of 2y squared plus 1. Get the y, okay? So here, so we have to square both sides again. So we have 2y squared plus 1. Getting in terms of y, we have y squared is equals to z squared minus 1 over 2. And get the derivative of the left with respect to y and to the right with respect to z. So we have 2y dy, okay? And we have now 1 half derivative of z squared minus 1 is simply 2z dz. So the 2's will cancel here, okay? So you are left with this value, 2y dy is equals to z dz. And as you can see here, in order for us to use this y dy, okay, let me just rearrange this first into y dy so that the 2 will become 1 half z dz on the right side. Okay? So, in our integral, we can rearrange the integral by this. Isolate, strip 1y here so that we have y squared, okay, y squared multiplied by 2y squared plus 1 multiplied by y dy. So we can use the y dy value here of 1 half z dz. So again, that's it. We can now integrate this. Integral of y squared, we have the value of y squared here, and that is given by z squared minus 1 over 2, that is the y squared, multiplied by the square root of 2y squared plus 1, that is simply, here in our algebraic substitution, that is simply equal to z, multiplied by y dy, that is simply 1 half z dz. I could also factor out 1 half here, so that if we're going to simplify it, 1 half times 1 half, this 1 half times 1 half, we can factor it outside the integral. So we have 1/4 z squared minus 1 times z dz. So now we can simply evaluate the integral of this. So we have z squared, the product of these two is z squared, multiplied by this distributive. So we have z raised to 4 minus z squared, and that is dz. So that if we're going to evaluate that integral by power formula, we have now z raised to 5 over 5 minus z cubed over 3 plus c. Okay? So distributing, we have 1 over 20 z raised to 5 minus 1 over 12 z cubed plus c. Now, back substitution, what are we going to do is z is equals to square root of 2y squared plus 1. So we have now 1 over 20 multiplied by square root of 2y squared plus 1 raised to 5 minus 1 over 12 times the square root of 2y squared plus 1 raised to 3 plus c. Or in other words, we have 1 over 20 times 2y squared plus 1 raised to 5 halves minus 1 over 12 times 2y squared plus 1 raised to 3 halves plus c. And that should be our final answer. Okay, I hope that is clear. Let's go now to number 3. Okay, for number 3. So for number 3 is, let's go back to our question. So integral of x cubed dx over x squared plus 1 raised to 3. So let me just rewrite the question. Number 3, I'm sorry. Number 3, this should be number 3. The integral of x cubed dx over x squared plus 1 raised to 3. Let me just rewrite this line. Okay, so now we are going to let z equal to x squared plus 1. Okay, x squared plus 1 without the power. Of course, we can do that if this is in terms of square root. We can actually include the square root. But since this is not raised to 1/2 or in any square root, so we have to use only the inside function. So we have, but it's not limited to that. You can always include also the cube, but the drawback of that is that we will be having a hard time computing our integral. So here's the key. So z is equal to x squared plus 1. So get x in terms of this equation. So we have now x squared is equals to z minus 1. Okay, so derivative both sides, 2x dx, and the derivative of z with z minus 1 with respect to z is simply dz. Okay, and again, x dx is equal to 1/2 of dz. We can extract x dx from above by stripping off 1x here. Okay, so that we can substitute the 1/2 dz. So from the above integral, so we have the integral of x squared multiplied by x dx over x squared plus 1 raised to 3. So that we can substitute the integral of x squared is simply z minus 1. X dx is 1/2 dz over x squared plus 1 is z raised to 3, which is cube. We can factor out the 1/2 outside the integral so that we have 1/2 the integral of z minus 1 over z cube dz. Okay? So by applying the properties of integral, so techniques, we have 1/2 multiplied by the integral of z over z cube dz minus the integral of dz over z cube. Okay, so we can see here that these two z's will cancel, leaving the denominator as z squared. So we have now 1/2 the integral of 1 over z squared dz minus integral of dz over z cube. And it's much easier if you're going to integrate it by a negative exponent. So we have now 1/2 the integral of z raised to negative 2 minus z raised to negative 3. Let's put it back together, a dz. Okay, so if we're going to evaluate the integral of that, we have now 1/2 multiplied by z raised to negative 1 over negative 1 minus z, okay, this is negative 3 plus 1, that should be negative 2 over negative 2 plus c, and we have now to simply simplify this. So we can bring down the z raised to negative 1 to its denominator. So 1/2 times z raised to negative 1 over negative 1 is negative 1 over 2z. Okay, so as we can see here, we have a minus sign, then a negative, so that should be positive. Okay, but we have a 1/2 here, so we can distribute the 1/2 so that it becomes 1/4, and bringing down the z raised to negative 2, we have now 1/4 z squared plus c. And it's now time to substitute it back to its original variable or what do you call this? The z. Okay, the z is equals to x squared plus 1. So that must be negative 1 over 2 times x squared plus 1 plus 1 over 4 times x squared plus 1 raised to squared or 2 plus c. So that should be our final answer. And again, the same process that we did for the integral, right? Integration by substitution, algebraic substitution. So for our number 4, okay, so for number 4, we have here the integral of x cubed times x squared plus 1 raised to 65. So we have number 4, the integral of the x cubed multiplied by x squared plus 1 raised to 65 dx. Okay? So we have to choose z as x squared plus 1 and get in terms of x. So x squared is now equal to z minus 1. Derivative both sides, implicit. So we have now 2x dx. Z minus 1 with respect to z is dz. Okay? And then, as usual, we're going to get x dx here. Okay, because we can factor out 1x here and multiply it with the dx here. So we have x dx is equals to 1/2 dz. Okay, and we can now substitute. So our given integral can be rewritten as this, So we have x squared times the x squared plus 1 raised to 65. Multiply it by x dx, wherein our x squared is simply equal to z minus 1. Our x squared plus 1 is equal to z raised to 65. Okay? X dx is simply 1/2 dz. Okay? So we can factor out 1/2 outside of the integral so that we have 1/2 z raised to 65 multiplied by z. That should be z raised to 66. That's right. Minus z raised to 65. Evaluating that integral with respect to dz. Okay, so we can apply our formula. So we have 1/2 raised to 7 raised to 67 over 67 minus z raised to 66 over 66 plus c. So now, if we're going to distribute 1/2, what will happen is z raised to 67 over 67 multiplied by 2 is 134. Okay, 134 minus z raised to 66 over 66 times 2 is 132. Okay, plus c. Am I correct? 67 times, yes. Okay, 60, 61, 20 plus 1. Okay. So we can now back sub the value of z. So we have now x squared plus 1 raised to what? 67 over 67 minus x squared plus 1 raised to 66 over 66 plus c. So this should be our final answer. Okay, down to our last number for this topic. So we have now the problem number 5. Problem number 5 is, I think, very similar with number 1. Okay, so we have to get now the integral of the 2x plus 1 over square root of 4x minus 1 dx. Okay, we have to let z again equal to the square root of 4x minus 1, and we have to square both sides for us to get that in terms of x. So we have 4x minus 1. Getting that in terms of x, we now have x is equals to z squared plus 1 over 4. And differentiating both sides with respect to x to the left, with respect to z to the right, that is dx is equals to 1/4 z squared plus 1. The derivative is 2z dz. So 2 over 4 will become simply 1/2. So we have 1/2 z dz here. Okay, and yes, we can now substitute. So we have the integral of 2 times x. Our 2 times x, the value of x is z squared plus 1 over 4. Okay, plus 1, that is the 2x plus 1 here. Multiply that by dx, which is 1/2 z dz over, okay, over the square root of 4x minus 1, that is simply equal to z. Z is here, will cancel. We can factor out 1/2 outside of the integral. I mean this 1/2. So this would cancel. Okay, 2 over 4 is simply this. Okay, so that should be the integral of z squared plus 1 over 2. Okay, so plus 1. So we can now put here the dz. Okay, so let's distribute again the 1/2. So for an easier integral, so we have z squared plus 1 over 2. Okay, plus 1. We have here the 1/2 dz. Distributing the 1/2, we have now the integral of z squared plus 1 over 4 plus 1/2 dz. Okay, so what are we going to do is to integrate that both sides. So we have integral of z squared plus 1 over 4 dz plus the integral of 1/2 dz, of which we know that we can factor out the constant 1/4 integral of z squared plus 1 dz plus 1/2 simply the integral of dz. So we have now 1/4 times the integral of this z cubed over 3 plus z, okay, plus the 1/2 z plus, don't forget the z, the plus c, I mean. So again, we have to distribute this z cubed over 12 plus z over 4 plus z over 2 plus c. Okay, and since this is we can add this 2, so that should result to z cubed over 12 plus 3z over 4 plus c. So that's it. Now back substitution. Okay, back substitution. So we have now z is equals to square root of 4x minus 1. So we have now the 4x minus 1. Okay, since that is a square root, we have to include minus 2 in the denominator, so it's raised to 3. So we have 3 halves over 12 plus 3 times z, 4x minus 1 raised to 1/2 because of its square root over 4. Okay, plus c. Okay, and now we have the answer. Okay, so what we did here a while ago is to combine the two z's. So we have the 1/4 plus 1/2 is 3/4 z. So that we can simplify the expression. Okay, so that's all for integration by algebraic substitution. And I do hope that you learned something. If you like this video, don't forget to share it with your friends. And don't forget to hit the thumbs up. And please subscribe to my channel for more videos, including integral and physics. So thank you so much for listening, and God bless you.